Pleasant day to everyone. Today we're going to discuss Module 2, Unit 1, Subject CE 2221. So in this lecture, we're going to discuss kinetics of a particle, specifically force and acceleration. So to start off, we define kinetics as a branch of dynamics that deals with the relationship between the change in motion of a body and the forces that causes this change. In other words, kinetics is the analysis of the force or the forces that would cause motion or change in position, velocity, or acceleration of an object. Therefore, simplifying, kinetics is the study of forces that causes motion. So the basis of our analysis in kinetics would basically be Newton's second law of motion, in which it states that when an unbalanced force acts on a particle, that particle will accelerate in the direction of the force with a magnitude that is proportional to the force. The second law of motion, or Newton's second law, also referred to sometimes the law of acceleration, aside from the first statement that we just have mentioned. And based on the factors that would affect motion, we could now define the law in terms of the relationships of our factors. So Newton's law could also be stated as the acceleration of object being directly proportional to the force applied and is inversely proportional to its mass. Or mathematically, we could write this as m is directly proportional to the F divided by A. And from this equation, mass here is a constant value, which is a quantitative measure of the inertia of an object or the resistance of the object to motion or the change in velocity. And from this equation, we'll now be able to derive what we call the equation of motion, which is force equal to mass times A. And then please take note that the equation F equal to ma will have limitations. So for this, F equal to ma has been given limitations by Einstein and Schrödinger. Okay? So for Einstein, he placed limitations in the equations by his development of the theory of relativity, in which this equation, F equal to ma, will not apply in objects that are moving at the speed of light or beyond the speed of light. And then, for Schrödinger, he invalidated the equations, meaning the equation, this one, is not applicable for objects under the atomic level, meaning very small size, yung mga objects that needs to be seen through the microscope. So this is not applicable. And this is not also applicable for objects that are moving very close to one another. Okay? So we have Newton's law of gravitational attraction, which was developed after the three laws of Newton has been developed. So this was a later development or principle by Newton. So in Newton's law of gravitational acceleration or attraction, we are given the equation F is equal to G times the products of the masses of two particles divided by r squared, wherein F is the force between the two particles, G is a universal constant of gravitation, which is an experimental value at 66.73 times 10 raised to negative 12, that's meter cubed per kilogram second squared. And then we have M1 and M2, which are the masses of each of the two particles, and R, which is the distance between the centers of two particles. So basically, Newton's law of gravitational attraction would simply define that the farther away two objects or two particles are, it means that there is lesser force between them. And at the same time, if two particles are near each other, it means that the force between them will be very high. Okay? So basically, in Newton's law of gravitational attraction, the force now is dependent on the distance between the particles. So analogy, kung LDR, usually, mahina ang force between the boyfriend-girlfriend kaya naghihiwalay. So kung lagi kayong magkasama naman ni friend 1, tapos ikaw si friend 2, lagi kayong magkasama, magkadikit, maliit ang distance, then it means malaki yung force between or malaki yung attraction between the two of you. Kayo yung dalawang particle. So that is now Newton's law of gravitational attraction. The further two objects are, the lesser the force. The nearer the two objects, particles, are together, then the force is higher. So from this equation, the weight now of an object can be derived, or the equation for weight can be derived, which we use as weight is equal now to mass times g, wherein mass is equal to, or m here is equal to the sum of m1 and m2. Okay? So g, as we all know, is already equal to 9.81 meters per second squared. So next we have the equation of motion, which we have defined as F equal to m times A. So whenever there is more than one force that would act on a particle, the resultant force is determined by the vector sum of all the forces acting on that particle. Thus we have the resultant force is equal to the summation of the forces acting. Thus, we could also write that the summation of the two of the forces acting on a body can be computed as m times A. Okay? So let's see. We have here a particle wherein it is acted upon by F1 and F2. And because of F1 and M2, there is an equivalent acceleration that resulted from these forces. So, given now this diagram, we can now say that for F1 and F2, drawing now our force body diagram, your FBD, we can now take our resultant force. Okay, so this is the sum of F1 and F2, which can now be related to a kinetic diagram, which shows that Fr is simply equal to the mass times the acceleration. Okay? So still under the equation of motion, when we apply the equations of motion on particles, it is very important that the acceleration of your particle would be measured with respect to a reference frame, which is either a fixed point or position, or that point would be translating a constant velocity. So, why? Because in this way, your observer, ikaw na nagko-compute or nag-observe ng motion ng particle, will not be accelerating. And thus, the measurements of the particle acceleration will be the same from any reference point. Okay? So, ito yung ginagawa natin sa kinematics wherein we have a reference frame. Okay? So, that reference frame will always be a fixed or will have a constant velocity with respect to the moving particle under observation. So that fixed reference point or fixed reference frame is what we call an inertial frame of reference. So ikaw yung observer nandito, hindi ka gumagalaw, tapos ino-observe mo yung path or yung motion ng particle. Or you could be moving, but you should be moving at constant speed or constant velocity as you are observing this object. Okay? So the inertial frame of reference is also referred to as Newtonian reference frame. Okay? So next, we have the equation of motion for systems of particles or a particle system. So given an isolated system of particles within an enclosed region of space, so this is the region space. So may particles tayo sa loob. So given this one now, so at an instant, we choose an arbitrary ith particle. So any particle we choose. So let's say we have this one. So this particle I will have mass I, which will be subjected to a system of internal forces and a resultant external force. So take note that for this I, so palakihin natin, this is subjected to an Fi, which is a resultant of all the forces acting on the particle by the other particles. Okay? And then we have capital Fi, which is represented by the resultant external force, which are the other forces acting on the particle that is not found in the system. So these external forces would include your gravitational force, electrical, magnetic, or any other contact force of other particles that is not part of your system. Okay? So in this case, the sum now of Fi, external force, and your internal force can be written as equal to the mass of the ith particle times its acceleration. So with that, so applying the equation of motion, so summation of the resultant external force plus summation of your internal forces is equal to MIE. So with this, the internal forces now will be resulting to 0 as it's simply equal to the positive negative values of the forces internally. Okay, so magka-cancel out lang sila. So we could simplify now this equation simply as summation of the external force equal to the mass times the acceleration of the ith particle. So simplifying again, then applying Rg. So this is your center of gravity. So or center of mass. So applying now Rg, center of mass, Rg times m, and then equating it to mi ai. Then deriving it will now arrive at equation of force. Summation of force is equal now to the mass times the acceleration of the particle about its center of mass. So this equation now would represent the equation of a motion to a body that is represented as a single particle. So, okay. So it's a system. Tapos, i-assume natin siya as a single particle. So you can apply this one in systems of particles. So M now will simply be the summation of the masses of the particles inside your system. Okay? So anyways, we'll have more examples of this later. So next, we have your equation of motion in terms of rectangular coordinates. So when a particle now will move relative to an inertial XYZ frame of reference. So we have here your frame of reference, XYZ. So meron tayong particle here. So this particle now will be moving three-dimensionally. So it can be defined by Fx, Fy, Fz, as well as its acceleration along X, Y, and Z. Okay, so this particle now will be defined by the acceleration and the force in terms of the ijk components or your unit vectors. So with this, our equation of motion, summation of F is equal to ME, can be written as the components of the forces along X, Y, Z equal to the mass times the sum of the components of the accelerations along ijk or XYZ direction. So similarly, this equation now, from here, we could write our three scalar equations in which we have F, or the components now of our forces, Fx is equal to Mex, Fy is equal to Mey, and Fz equal to Mez. So ito yung ginagamit natin. So kung 2-dimension, ang gagamitin lang will be xy. Kung 3-dimension, we use this one. So that we could get the magnitudes of the force and the magnitude of your accelerations. Okay? So that's it for our examples for Newton's second law, or the relationship between forces and acceleration. So we have here our references for more examples. You can read Dynamics of RC Hibbeler, or there are other examples found in your module. So thank you for listening.